So far we have discussed about the contact and non-contact forces, right? Now we are going to discuss about pressure. So students, what is pressure? Let me tell you that pressure is produced when a force acts on an object. And in most of the cases, an object exerts force on another object by making contact with it or by touching it. Okay? Now, here we'll describe how the effect of force applied by one object on another object depends on the area of contact between the two objects. Because whatever force we are applying, the effect of that force depends on the area which is in contact between the two objects. So how effect of force depends on the area of contact? We'll try to understand that. And this point will become clear from this example. Suppose if we push hard on a piece of wood with our thumb, what will happen? Do you think the thumb goes into the wood by the force which we are exerting with our thumb? No, right? Our thumb does not go into the wood. But if we push a drawing pin into the wood with the same force of our thumb, what will happen? You will see that the drawing pin goes into the wood, right? So, why our thumb does not go into the wood and our pin easily went into the wood? Let me explain this. See, students, our thumb does not go into the wood because the force of our thumb is falling on a large area. The force of our thumb is falling on a large area of wood, hair, due to which the force per unit area on the wood is small. The force here is small because the thumb is exerting its force on large area. So force on per unit area is small. Now look at the drawing pin. The drawing pin goes into the wood because the due to this sharp tip of the drawing pin is having very sharp tip. Now the force of thumb is now falling on very small area. So what happens? The force per unit area becomes large here. So the force on per unit area becomes large in case of drawing pin, but in case of thumb, the force per unit area becomes small. So what will happen? The pressure is nothing, it's the force acting on a unit area of the object. Force, pressure is actually the force which we are acting on the unit area of the object. So here the unit area we are taking of wood, we are talking about the wood. So the force of thumb produces small pressure because the force acts on the large area of wood. But the same force of our thumb produces greater pressure when it acts on the very small area of wood through the tip of drawing pin. So let me tell you that the intensity of pressure, that the effect of force, it depends on the area of the object on which it acts. Okay? So pressure is the force acting on a unit area of the object. Now, to obtain the value of pressure, we should divide the force acting on an object by the area of object on which it acts. So, our formula would be pressure is equal to force divided by area. And this formula gives the relationship between the pressure, force, and area. Now we'll give the units in which pressure is measured. The SI unit of measuring force is Newton, right? So for force we are having the unit of Newton. The SI unit of measuring area is square meter, meter square. So what would be the SI unit of measuring pressure? That is Newton per square meter, right? Here I have written this Newton per square meter, and which is also called Pascal. So students, tell me what is 1 Pascal? Define 1 Pascal. So 1 Pascal is nothing but 1 Newton divided by 1 meter square, right? So when 1 Newton of force is exerted on 1 meter square area, so our pressure would be, our effect of force would be equal to 1 Pascal. Pascal is a very small unit of pressure. Bigger unit of pressure like kilopascal, that is also used. And the symbol for kilopascal is this. Okay. And 1 kilopascal is equal to 1000 pascals. Okay, students. So we'll get the value of pressure in Newton per square meter or pascals. Okay. Now the area, since the area is in the denominator of pressure formula, it means larger the area of surface, smaller will be the pressure produced by the given force. And smaller area of surface, larger will be the pressure produced by the same force. So that is why the area of pointed end of drawing pin, it was small, due to which force produces large pressure, and that large pressure pushes the drawing pin into the piece of wood. So it's clearly shown here that pressure depends on two factors: force applied and the area over which force acts. So the same force can produce different pressures depending on the area over which it acts. For example, when force acts over a large area of the object, when area is large, and force is acting on that large area, what will happen? It will produce small pressure, because area and pressure are inversely proportional to each other. But if the same force acts over a small area is small, then it produces a large pressure. Remember this thing, okay? And let me tell you one more important thing, that weight of a body, that is also a kind of force. Everybody is having a weight, and that weight is nothing but force. And the weight always acts in the downward direction. So it means the weight of a body, the force, always acts in the downward direction. Okay. Now, students, we have just studied that pressure is the force per unit area. And this definition of pressure can be used to explain many observations of our daily life. But yes, important point that is to be kept in mind is that the same force produces less pressure if it acts on a large area, and it can produce high pressure if it acts on a small area. Now tell me, students, you might have observed that the school bags are having wide straps, right? Why the school bags have wide straps? Why not narrow straps? Basically, school bag has wide straps made of thick cloth so that the weight of bag may fall over large area of the shoulder. And when weight falls over a large area, weight is nothing but force, and when force falls over a large area, what would be the pressure? It would produce less pressure on the shoulder, and due to less pressure, it's more comfortable to carry the heavy school bag. But if the school bag has a strap that is made of thin string, then what will happen? Weight will fall over a small area because string is very thin. When weight falls over a small area, it will produce large pressure on the shoulder, and it will become very painful to carry the heavy school bag. In fact, you might have noticed, sir, that a person which is employed to carry heavy luggage is like they always place thick round piece of cloth on their head, right? When they have to carry heavy loads like heavy suitcases of passengers, they place the thick round piece of cloth on their head. Why? Because by placing that, potters increase the area of contact of load with their head, because area gets increased now when we place thick round piece of cloth. And when area increases, what will be the pressure? Pressure on head gets reduced and it becomes easier for them to carry that heavy load. Okay, so this is an important application on the basis of pressure. One more thing is there. uh, why a sharp knife cuts better than a blunt knife? Why? See, a sharp knife that is having very thin edge to its blade, right? Sharp knife cuts objects better due to its very thin edge. The force of our hand falls over a very small area of the object because the edge is very thin now. So force will act over a very small area of object, and that produces large pressure. And that large pressure cut the object easily. But on the other hand, if we are having a blunt knife, which is having very thick edge, so blunt knife does not cut an object easily because due to thick edge, force falls over large area, and that produces less pressure, and this less pressure cuts the object with difficulty. So whenever we require some things to cut easily, we always use razor blades which are having very sharp edges so that they may produce large pressure to cut things easily. Even an axe that also has a sharp edge to cut things, to cut log of wood easily. So this is the reason why sharp knife cut better than a blunt knife. Okay, tell me one more thing, that um, why the tractors, why in tractors we are having broad tires. In tractors we are having broad tires. Why? Because when the tractor is having a broad tire, there is less pressure on the ground, and when pressure is less, tires do not sink into comparatively soft ground in the fields, because we are using tractors in the fields and there we are having very soft ground. So pressure exerted will be less, and when pressure is less, tires will not sink into the field. Okay, in fact, wide steel belt is provided over the wheel of army tanks. Might you have observed this? There's a wide steel belt which is provided over the wheel of army tanks so that they exert less pressure on the ground and do not sink into it. One more thing is here, when a man stands on a cushion, then the depression, when we stand on a cushion, the depression is much more than when a man lies down on it. Why? Because when a man stands on a cushion, then only his 2 feet are in contact with the cushion. So due to this, weight of man falls on a small area of cushion, which produces less pressure, and which produces large pressure. And when large pressure is there, it causes a big depression on the cushion. But on the other hand, when the same man is lying on the cushion, his whole body is in contact with cushion, and the weight of man falls on large area. And when area is large, the pressure produced will be less, small, and that small pressure produces very little depression on the cushion. Similarly, in football boots, we are having studs in football on football boots. Why? Because what happens, the stud on football boot, that will have small area of contact with the ground, right? And when area of contact is less, the pressure exerted will be more, right? So the pressure under the stud is high enough for them to sink into the ground, and that sinkness into the ground gives them extra grip. So that is why we are having football boots, we are having studs on football boots. Okay, so I hope I have clearly explained some everyday observations which are based on the pressure.